Let's see what happens to the price of a bond if you hold it over time based on whether it is a discount bond, whether it's a premium bond, or it is selling at par. So we are going to assume that nothing else is changing, so interest rate remains the same, nothing else, like holding everything else constant. If you hold a bond that is a discount bond for the from now till its maturity, what happens to its price? And then we'll also see why that change is happening. So we'll do this for a discount bond, and then for a premium bond, and then finally for one selling at par. All right, so our yield to maturity is 10%. We have three different bonds. The first one, let's say, pays a coupon payment of 8%, so a coupon interest rate of coupon payment of $80, so a coupon interest rate of 8%. The face value of this bond is $1,000. So we want to see what happens to the value of the bond from now till its maturity in year 5. So from 0 to 5. So if it is now and there is 5 years remaining to maturity, that means n is equal to 5. Next year, the maturity of the bond will be 4. That means 4 years till maturity, and then 3, and then so on. So 3, 2, 1, 0. Right, so today the maturity of the bond is 5 years, so that's why our n is 5. So if you're finding the value of a bond, usually what we do is we just find the present value of a bond, rate is equal to 10%, NPER is equal to 5, payment is this coupon payment of $80, and then future value is our face value of 1,000. And this gives us the value of the bond, that today this bond should be worth $924.18. Right? So, but what we're doing in this calculation though is we are calculating the coupon payments and the face value at the same time. To understand what is happening to the price of a bond, we are going to break it down to the present value of the coupons, just to see what is happening to the value of those coupon payments over time, and what is happening with the value of the face value over time. Right, so if you were to solve this, let's fix a few things. So our yield to maturity, this is not changing over time, so let's blink that. N will change, so next year is going to be 4, 3, 2, and so on, so I'm not going to fix that. The coupon payments are not changing, so for all the year calculation, this coupon payment will remain the same. Same thing for the face value. The face value remains at 1,000. Right. So if I drag this along, you can see how the price of the bond is changing. So let's call this price of the bond. So the price of the bond, if this is a discount bond, you can see that over time, the value of this discount bond is going up, assuming everything else remains the same, nothing is changing. Realistically, that's not the case. A lot of variables do change over time, but say nothing was changing, we just want to understand theoretically what happens to the price of a discount bond as it moves closer to maturity. So you can see as this bond moves closer to maturity, so maturity goes from 5 to 0, the price of this discount bond goes up until it matches its face value. So that's what happens to the price of a discount bond over time, holding everything constant. Let's try to understand why this is happening. So to understand that, we're going to split this up. We're now going to look at the present value of the coupon separately and the present value of the face value separately, right? So we're going to look at what is happening with the coupon payments and what's happening with the face value. So when you're holding a bond like this, you're receiving payments on two ends. One, you're receiving coupon payments. So that's one benefit of holding this bond. And then the other benefit of holding this bond is the face value, the 1,000 that you're going to be receiving at the end of the bond's maturity. But as you move closer and closer to maturity, you will notice that there are fewer coupon payments. For instance, this year you have pending 5 coupon payments. The next year there is only going to be 4 remaining coupon payments, and so on. So if we calculate just the present value of the coupon payments, that means we're not going to take into account this $1,000. Let's see what's the present value of the coupon payments. So 10%, today there is 5 coupon payments remaining. These coupon payments are worth 80, and we're just finding the present value of the coupon payment, so we are not going to take this face value right now, so we'll keep this at 0. The reason we are doing this is we are trying to understand why is this price going up over time? Why is the price of this discount bond going up over time? To understand that, we want to see the dynamics between coupon payments and the face value. So looks like the value in year 0, or right now with 5 coupon payments remaining, the coupon payments are worth $303 in today's dollars. I'll do the same for the next year. To do that, let's fix a few things. The yield to maturity, we're assuming, will not change. It will remain constant at Control-C. It will remain constant at 10%. This N will change over time, so I don't want to fix that. And then your coupon payments are not changing. And that's 0, so it's going to stay as it is. Right? So if we solve for this, we can see that the value of these coupon payments are decreasing over time, which makes sense because you're receiving fewer and fewer coupon payments. So if you have 5 coupon payments, they're going to be worth more. If we're just receiving 4 coupon payments, that's worth a little bit less. So next year, if someone were to buy these coupon payments, the valuation of the coupon payments at that point in time is going to be lower just because they're receiving 1 fewer coupon payments. So that's why the coupon payments are decreasing over time. Now let's do the same for the present value of the face value. So right now we're not going to look at the coupons. We'll just look at this $1,000. What happens to the value of this $1,000 as you move closer to maturity of the bond? Right, so if we were to price this bond without the coupon payments, so present value, rate is 10%, NPER, N is 5. Remember, we're not including the coupon payments at this part, so that we'll leave that as 0, and the face value is 1,000. Okay. So that gives us 690. So in year, like right now, when there is 5 years remaining to maturity, this $1,000 in today's dollars is worth 620.92 because you're having to wait an additional 5 years. The yield that we're seeking is 10% on that 1,000, like overall a 10% yield. So this amount is much smaller than that actual 1,000 that you will receive because we're having to wait for that. All right, so let's do the same thing for the remaining years. To do that, I will need to again use absolute referencing for the yield, and we want that to change, and absolute referencing for the face value. Okay. Let's drag this down. All right, so what's happening with the present value of the face value? We can see over time it's going up, which makes sense because from right now in year 0, you'll have to wait 5 years in order to receive the $1,000. Whereas in year 1, the maturity of the bond becomes 4 years, so you'll only have to wait 4 years to receive the same 1,000, so it's worth a little bit more. When you are at that particular year, you are no longer waiting for that face value to receive that face value. So if you receive it at that point in time, it's going to be worth exactly the same, right? Because no time has passed, you're receiving it right away. So if any were to buy this bond 4 years from now, their valuation at a 10% rate for that 1,000 would be 909, right? You're closer to that 1,000, so it's worth more in that period's time. All right, so we calculated the coupon payments separately and the face value separately. You'll see if you add them up, you'll get exactly the same as the price of the bond. This is not surprising. It's just when we calculate the price of the bond, there is no need for us to calculate these separately. So we do it in one step. But if we were to analyze it and see what's happening, sort of break it down and see what's happening, that's when we would need these two payments separately. Right? So again, it's just for illustration purposes, nothing else. Calculating the present value of the coupon payments and present value of the face value separately. All right. So on one hand, we can see that as we move closer to maturity, the value of the coupon payments decreases because there are fewer coupons remaining. But as we move closer to maturity, the value of the face value increases because we're that much closer to receiving that 1,000. Right. So there is two opposing movements that are happening. On one side, you have a downward pressure on the price. That is, you have fewer coupon payments, so over time the price will decrease of this bond. But on the other hand, you're moving closer to the face value, so the value of the bond increases based on, because of that. So now we want to understand which force is stronger. So if we look, before we do that, let's put a negative sign before this, just so that all our numbers become positive and it's easier to understand. Another negative sign here makes it all positive, and then another negative sign here. Okay, so now everything's positive. So now let's try to see which of the two forces are stronger. So for this, we'll take the other way, right? So the future, so for the price, say we are in year 4, so price of that year minus from the previous year. So it looks like prices are decreasing. The value of the coupon payments are decreasing by 49. But if we look at the price difference for the valuation based on the face value, which is worth 683 which will be worth 683 next year, and then this year it is worth 620. So when we move to the next year, the value of this bond on one hand will decrease by 49.67 because we have one fewer coupon payment. On the other hand, the price will go up by 62.09. There will be an upward pressure for the price to go up by 62.09 because it's coming closer to that $1,000. If we look at the net difference between the two, let me insert another line here. If we look at net difference, so if we add them up, the two forces, you see that this is greater. The fact that we're getting closer to that 1,000, that force or that change is greater than the fact that we are losing one coupon payment, right? So the difference or if we add them up, we get 12.42. If you look at the price difference, you'll see it's exactly the same. The price difference is 12.42. If we do this for all the remaining years, you'll see it holds for all the remaining years too. Right? So in conclusion, what's happening is the force for going closer to the face value is greater than the downward force of losing coupon payments in the case of a discount bond. Now let's try to see intuitively why that is happening. That is happening because when you're holding a discount bond, you are the attractive feature of the discount bond is that you're paying a lower price for it. So you pay 924 and you get to receive the 1000 face value at the end. So for a discount bond, the feature that is the most attractive for the discount bond is the face value. That paying a lower price to receive the same 1000 face value. The coupon payments are really not the major attraction for a discount bond. So that's why for a discount bond, even if we're losing a coupon payments, yes, the valuation decreases, but the fact that we're getting closer to that $1,000, that force is much stronger than the loss in the coupon payment. Okay. Next, let's do the same thing for the valuation of premium bond. So let's add the price there too. So for a premium bond, now say the coupon payments are 120, so that's a coupon interest rate of 12%, while the yield to maturity is 10%. So this is a premium bond because the coupon interest that you're receiving is greater than the yield or greater than the market interest. Let me delete a few. Okay, just to bring that up. Right. Below that, there is a calculation done for bond selling at par. So let's calculate the price first. So the price of this premium bond is equal to present value. Rate is 10%. NPR is 5. Payment is now 120, future value 1000. Right, so the value of this bond is 1075. We'll put a negative sign to begin with. So 1075.82. So this is clearly a premium bond. Let's see what happens to the value of this bond as we move closer to maturity. Assuming that the yield is not changing, interest is not changing. The face value is the same 1000. The coupon payments are also the same. So the only thing that's changing is just we're moving closer to maturity, so the time or the maturity of the bond is changing. So if we drag this down, you can see as we move closer to maturity, that means we're moving from year 0 to year 5. The value of the bond decreases till it matches its face value. So if you're holding a premium bond, if nothing else changes, then you can expect the value of this premium bond to decrease over time as it moves closer to maturity. Let's do the same calculation for the coupon payments and the face value. So present value, rate, comma, n of 5. Sorry, not this 5. Let's use this one. 5. Payment of 120, and then for just the calculation of the present value of the coupons, we are going to keep the face value as 0. Let's add a negative sign to make this negative. Oh, my bad. And this one. F4. Okay, same idea. As you move closer to maturity, the value of the coupons, the present value of the coupons are decreasing because there are fewer coupon payments remaining. For the present value of the face value for each of these years is equal to present value, rate, and payment we're going to assume is 0 because we're just finding the present value of the face value. All right, and a negative sign, and to drag this down, I'm going to bling our interest rate and our face value. Okay. Drag this down. Right. So as we move closer to maturity, the value of the face value goes up. And if you notice, it's exactly the same as this, which is not surprising because we're doing the same calculation. We're finding the present value of 1,000 as it moves from year 0 to 5, right? We did the exact same thing for the discount bond. So again, two opposing forces. On one side, the present value of the coupon payments are decreasing because there are going to be fewer coupons as we move closer to maturity, and the present value of the face value is increasing because we are that much closer to receiving the face value. If we now find the difference from the previous year, so that's 74, drag it down, find the difference for the face value. Again, it'll be exactly the same as our previous calculation. So now you can see that yes, there is a downward pressure on the price for the coupon payments and upward pressure for being closer to the face value. But out of the two, the negative fall because of coupon payments is actually larger than the positive gain that we're going closer to the face value. So if we add them up, the two differences, then the negative pressure for losing the coupon payments is actually greater than the positive pressure of being closer to the face value. And if you want to take the sum between the two, that should give us exactly the same as the price. And if we take the difference, you'll see the difference is the same as the change in price from coupons and the change in change in value from the face value, right? So intuitively, why is this happening? This is happening because it's a premium bond, and for a premium bond, we're actually paying a higher price to receive those larger coupon payments. So losing the coupon payments is going to be it's going to be more impactful than going closer to the face value. So for a premium bond, the highlight of the bond is the coupon payments that you're receiving, because those coupon payments are larger than the yield or the market rate, not necessarily the face value that you're going to receive. So that's why losing those coupon payments have a higher impact than moving closer to the face value. So for a premium bond, as you move closer to maturity, assuming everything else remains the same, the value of that bond will decrease over time. This is for the bond that is selling at par. You're going to notice that, again, nothing changing. Then the loss in the coupon payments is going to be exactly the same as the gain in the present value of the face value, right? The sum or the value of this bond is not changing over time. Again, realistically, we don't really see this because a lot of things change, but just to understand the theory behind what would happen to the value of a bond over time, it's best to hold everything else constant so that you can just understand the valuation based on just the time as the value of the bond changes over time, or how the value of the bond changes over time. So here's a graphic. This is slightly different. This is for a bond with 13% and 7% coupon rate instead of 12 and 8 that we did in the example, but just to illustrate graphically what happens to the value of the bond. So this is for a discount bond. You can see it goes up from 816 to 1,000 as it's moved closer to maturity. So its maturity years are decreasing from 10 to 0. And then for the premium bond, the value is decreasing over time. For the one selling at par, it remains constant.